Statics is a fundamental building block for engineering in structural and mechanical fields. Statics uses a series of generic assumptions presented in physics used to describe a mechanical system. These systems use Newton's first, second, and third laws of motion. They are depicted by free body diagrams used to simplify the system in question for analysis. The change in velocity of the inertial system or control volume is zero. A static system is evaluated at rest. A system at rest stays at rest, and a load acting on a load-bearing member is evaluated for the system externally at equilibrium. This is later translated to an internal load reacting within systems at various locations. Otherwise, the system is accelerating. The summation of the forces and moments at each joint are no longer zero. This affects the manner in which a solution is resolved. These systems are constrained correctly, are stated to be statically determinate. A statically indeterminate system is resulted from having more unknowns than equations. Generically, the system of equations for the location is 3 force equations and 3 moment equations evaluated along the x, y, and z axes. These solutions are evaluated internally and externally. The static system is built to withstand loading for minimal weight for the system requirements. Other solutions to static systems describe a series of machines are designed to transmit and multiply loads. Machines include the wedge, the pulley, inclined plane, wheel and axle, and screw and lever. The forces and moments on a system are said to be at equilibrium. These forces are resolved external to the system and transferred into the system with a series of complex vector geometries used to solve and analyze the system. The system are generically in 2 and 3 dimensions and use directional cosines, force loads, and moments to determine the loading on each beam member. Favorites of static analysis include the distance formula, normalization of line of action, manipulation of geometry, law of cosines, law of sines, and law of vector addition, including the dot product and cross product. The normal vector to the plane describes the plane with which the forces are acting, is defined by the cross product of that plane. The use of the dot product and cross product are used to decipher the loading along the line of action. The moment and or ordinate systems to describe the object features. Those are said to transfer along the line of action. The system is developed by use of the principle of transmissivity, allowing the loads to transfer along the line of action. This projection along the line of action allows